Okay, so we did autoionization of water in the last class, and there we discussed that concentration of H plus times concentration of OH minus is Kw. Kw, the ionic product of water, the value is 1.0 times 10 raised to power minus 14 at 25 degrees Celsius. You change the temperature, Kw value changes. We did one question based on that. Okay, Isabella, no problem. Now, when you take the negative log of this, then negative log of all this thing, if you remember, I discussed that pH, pOH, pKa, pKb, pKw. What is this p? Small p in chemistry is negative log. Small p represents negative log. So when I take the negative log of this, then we discuss that we are getting an equation that pH plus pOH is 14. We have this equation. Then we have this equation that Ka times Kb. All these things we did in the last class, Kw. Then from here we have pKa plus pKb is pKw. pKw we know if you take the negative log of this number is 14. And we did questions based on that. So it means pH, pOH, Ka, Kb, pK, pKb, pKw, they all are interrelated. Then we did a relationship that if pH is more, then concentration of H plus is, then the value of Ka is pOH, concentration of OH minus, value of Kb, pKa, pKb. Ready to answer? If pH is more, then H plus is because it's negative log. No, Isabella, it's negative log. It's negative log of H plus, right? It's less. pH is less. We did questions like, for example, if pH is 9 and if pH is 3, out of these two, which one is acidic? Answer this, pH 9 or pH 3? Which one is acidic? pH 3 is acidic. Then remember we did one more equation that concentration of H plus is 10 raised to power minus pH. We did questions on that. And the concentration of OH minus is 10 raised to power minus pOH. Similarly, Ka will be 10 raised to power minus pKa. Kb is 10 raised to power minus pKb. All these equations we practiced in the last class. So if pH is more, then the concentration of H plus, I'm going to use this equation, children, this one, is 10 raised to power minus 9 molar. If pH is 3, then the concentration of H plus is 10 raised to power minus 3 molar. Which one is more? Which concentration is more? Minus 3. pH 3, more concentration of H plus. pH 9, less concentration of H plus. So if pH is more, then H plus is less. Agreed now? Mathematically, we have seen. If H plus is less, then it means the dissociation of the acid is less. then what happens to Ka value? Ka value will be less or more. If the concentration of H plus is less, Ka will be less. Very good, Sri. What happens to pKa? pKa is negative log. It is negative log. So it will be more. Same relation. pH is more, H plus is less. Ka is less, pK is more. Please write down this. What about pOH? If pH is more, now you know that pH plus pOH is 14. If pH is more, then pOH is less. OH minus is negative log, right? No. Oh, you are not, all of you are wrong. Kb is more. pKb is less. Okay, don't worry. Let me give you one example. Okay, we are going to consider here two solutions. Solution A, this is very important to understand, and after that we'll start with how to calculate pH of strong acid and strong bases. Solution A and solution B. The concentration of H plus is 10 raised to power minus 2 molar in the solution, and the concentration of H plus here is 10 raised to power minus 8 molar. Can you tell me which acid is stronger? Which solution has a stronger acid? Stronger acid, you know, is the one which is fully dissociated. Vinaya, very good. So this is stronger acid. Stronger acid. The other one is weaker acid. So which one has higher value of Ka? Higher value of Ka, which one? A. This one has higher value of Ka because it's stronger acid. It's going to dissociate more. It's going to give you more H plus. So Ka, I'm giving you the value of Ka also. Let's say Ka is 1.010 raised to power minus 3. No units, it's equilibrium constant. Similarly here, I'm giving you Ka 1.0 times 10 raised to power minus 10. No units again. Can you see the values of Ka, the magnitude? Okay, now can you calculate pH? Can you calculate pOH? Can you calculate Kb and pKa and pKb? So I gave you so many equations. What is pH? Negative log of concentration of H plus, which is Isabella pH. You are giving me pKa. Concentration is this, right? So what is pOH then? pOH. Now I'm going to use the equation pH, this one, 14 minus pH. This equation is 12, yes. What is Kb? Now I'm going to use this equation Ka times Kb is Kw. So Kb is Kw over Ka. Ka I have given you. So what is Kb? 10 raised to power 1.0 times 10 raised to power minus 11. No units. See this equation, I'm using Ka times Kb is Kw. What is pKa? pKa is negative log of this value. pK is You have understood how I calculated this value because you are not responding here in the chat. Is it clear? Because we need this equation later on also. That Kb is Kw over Ka. Now what is pKa? Check the pKa. 3. What is pKb? Take the negative log of this. Now here you can see that pKa plus pKb is 14. So in this question, in this solution A is acid. Okay, and when the concentration of H plus is more, I'm comparing it with solution B. It's not a strong acid. We can see that Ka value is less than 1, but is stronger than solution B acid. So I can say that here the concentration of H plus is more as compared to this one. This one is less. When H plus is more, Ka is more. You can see Ka is more. Here Ka is less over here. Because H plus is less, Ka is less. As compared to, I'm comparing A and B. Now, the way I fill this complete table, can you calculate the pH here? What's the pH for solution B? pH for solution B is 8. pOH is 6. Concentration of OH minus 10 raised to power minus pOH. 10 raised to power minus pOH. Keep practicing these equations. 10 raised to power minus 6 unit molar because this is concentration. What is Kb? Kb is Kw over Ka, and that is Kw, you know, is 1.0 times 10 raised to minus 14, and Ka is given to us. So what's the answer here? One point zero times 10 raised to power minus 3. Oh, 4. Sorry. No. Sanjana, 4. That is Kb. So what is pKa? pKa from here is 10. What is pKb? Is 4. Now you can compare them now. You can see that when the concentration of H plus is more, Ka is more, pH is less. Here, concentration of H plus is less, Ka is less, pH is more. Because it's negative log. If pH is less, pOH is more. If pH is more, pOH is less. Can you see that I'm comparing it? Kb, Ka is more, Kb is less, minus 11. Here it is minus 6. Here Kb, minus 4, sorry, over here. Kb is more. Concentration of OH minus here is more. This is more. Kb is more. So pKb is less. pKb is more. pKa is more. pKa is less. Can you see how they are related to each other? So this mathematical example is just to make you understand that when you take a negative log of any number, the number negative log value will be less. If it is 10 raised to power minus 30, if I say 10 raised to power minus 30, and if I say take negative log of this, answer is 30. So when the concentrations are very low like this, then pH will be like this. So understand this relation. So last question again, last time I'm asking question. Ready? Okay, I'm going to clear it. Shall I clear it? I'm going to clear it, children. Okay, here is the question. Try to answer, all of you. Just like more, less, more, less, more, less, like this. And stay with me. It's not that I'm asking something and you're answering something else. If you are unable to answer, then skip the question and try to answer what I'm asking at that time. Concentration of H plus is less. This is the question I'm giving you. pH will be yes. Ka will be Ka. Now I'm on the Ka value, so don't answer pH. Answer Ka now. Is less. Very good. pKa will be perfect. Now this part we have answered. Now I'm going to relate it with OH minus. If H plus is less, OH minus, concentration of OH minus will be yes. pOH will be pOH. KB, KB, KB is more. pKb, yes. Just like this, okay? So this comparison is very easy. We have done so many equations. Yes, Lasya, because they are connected to each other through Kw. You have these equations. Concentration of H plus times concentration of OH minus is Kw. And you have this equation that Ka times Kb is Kw. It's the outcome of this equation only. This relationship is the outcome of these equations. If H plus is more, OH minus is less. If Kb is more, K is less, like this. Because this Kw is a constant. It has a constant value 1.0 times 10 raised to power minus 14 at 25 degrees Celsius. So if this value is not changing, if you increase H plus, OH minus, they will decrease so that the product should remain this only. So anyone still struggling with it? So this question will be there. And we already did these type of questions in the last class. Now I'm starting with how to calculate pH of a strong acid and strong base. So first thing, write down this line, which I'm going to repeat many times as we'll discuss what is happening, So remember, whoever is stronger, whoever is stronger will control the pH. Control the pH means you're going to determine the pH of the solution, because solution means so many things are present. Now in that solution, whoever is stronger will control the pH. Okay, and the others, they will have no effect on the pH, or they are just spectators. Understood? Write down this line, because I'm going to use this line whenever it is needed. Stronger one. Stronger means, I think I told you last time also, stronger means reactive. Reactive. One more thing, maybe I told you to you people or maybe to some other group, I don't remember exactly. Equilibrium is favored by less reactive. You know, equilibrium has more products, less reactant. It means products are more stable. More stable means less reactive. So write on this line also. Equilibriums are favored by less reactive. Now, what's the meaning of less reactive? Means stable. Means here weak. weak acids, weak bases, weak your compounds. Weak compound means not reactive. Weak acids and bases, because we are learning acids and bases, so you can say weak acids and weak bases. Equilibrium is always dominated by less reactive because they are more stable. Equilibrium means stable. The system is more stable at this point. If you remember the energy profile for the equilibrium, like this. Remember we were discussing where is the equilibrium? Here. This is energy, free energy, which we are going to learn in unit 9. So equilibrium is the most stable form. It is the most stable form of the system with minimum energy. That mantra you already know. Stable means less energy. Remember, more attraction, more stable, less energy. Now you can say this also. More attraction, more stable, less reactive, or weak. Not reactive means weak, less reactive means weak. So write down these lines. We have to use them in answering many questions. So we are ready for strong acids. These are strong acids. Who is going to give me the formulas of all important 7 strong acids which we have done? 7 strong acids which we need to memorize for our examination. 7. 3 are non-oxo acids. So anyone with non-oxo acids? 3 non-oxo acids. Very good, Vinaya. HCl, HBr, HI. These are very strong. We are memorizing. We decided that we are going to memorize this chapter here only. Okay, then what are the oxygen containing acids which are strong, which I told you to memorize? There are 4 of them. HClO4, perchloric acid is written here. HNO3, nitric acid, written here, strong acids. HClO3, chloric acid, this is also strong. These are the important one. H2SO4. So keep practicing your strong acids and strong bases. Right now we are working with the pH of strong acids. So these are the strong acids you must know. Yes, very good, Lassia. Children, she has given all the formulas. I think last year you have written chloric acid twice. One is perchloric acid, other one is chloric acid. This is perchloric. ClO4 minus perchlorate. Okay, I'm going to erase this now. Okay, Sarayu, you're okay with all your strong acids now? Do not forget them. Okay, they are going to help us in the exam. HClO4 is a strong acid. So what is the meaning of strong acid, children? That they are 100% dissociated. Like this. Meaning of strong acid is that they are 100% dissociated. So I'm not going to make any rise table because there is no equilibrium here. The equilibrium is completely dominated by weak conjugate base. That's what I was trying to tell you. So here the reaction is totally on the product side because this is a strong acid. Strong acids, they react, they break down, and they give you weak conjugate base. So equilibrium, if I write on the equilibrium, then it's like this. There is hardly this, zero. It's completely on this side. So that's why we say no need of writing equilibrium. It's 100% dissociated. So this is reaction, initial, final. So please write on these things. Strong acids, strong bases, 100% dissociated. You have to write down initial and final. No rise table. No rise table. Remember rise tables we did in equilibrium? Here, no rise table. Okay. Now, what is the initial concentration of HClO4 given in this question? Read the question. Initial concentration of HClO4 is 0.250. How much H plus? How much ClO4 minus initially before dissociation? Yes, children? How much H plus initially? Isabella? Yeah, 0 and ClO4 minus 0. It's a strong acid, 100% dissociated. So finally, how much undissociated acid? How much HClO4? 0. How much H plus? How much ClO4 minus? Who is going to determine the pH? Whoever is stronger, like who is going to determine the pH? This H plus, this concentration. Yes, Shrihan. So what's the pH? Is it molarity? Yes. You're not going to take moles, okay? Molarity. Because by definition, pH is negative log of concentration of H plus. So we will never work here, we'll never use grams or moles to calculate the pH. We need molarity. So calculate the pH. Yes, Sarayu, you have your calculator? Calculate the pH. Mhm. Anyone doing? How many significant figures? 3, yes. So 0.602. Remember before decimal, whatever is there in the pH, pK, pKb, pOH is not counted. You'll count the numbers after decimal. What's the pOH? pOH is 14 minus pH. So I'm doing all these questions just to make you practice all the formulas. These questions are very simple, but still I'm doing them again and again so that you can memorize the formulas. 13.398. Yes. What's the concentration of OH minus? Concentration of OH minus is 10 raised to power minus pH. How much is that? 10 raised to power minus 13.398 molar. When you're going to plug in your calculator, it will give you some answer in scientific notation. Take this answer in 3 significant figures. You're understanding this? Okay, now let's answer this question. What are the major species present finally in the solution? So look at the final picture. Final picture. What are the major species? Mhm. Major species are concentration of H plus time and ClO4 minus. These are the major species. And water. Do you have HClO4? No. So from the final picture, you are going to check the species finally present in the solution. So what are the species present finally in the solution? H plus, ClO4 minus, and water. So these questions are very popular. Very, very popular. Ready for next? Calculate the pH of HNO3. So I'm going to make the table again. Let's do it very fast. HNO3, strong acid, weak acid. Strong acid. Strong acid means 100% dissociated, means no rise table, no equilibrium. It's totally on the side of is weak conjugate base. The conjugate base of a strong acid is weak, NO3 minus. This is your weak conjugate base. So equilibrium is dominated by weak components. I'm going to make initial and final. Complete the table, children. Give me initials. All of you, please type here in the initials. Fill these three blanks. For the final, these three blanks. Yes, please. Initial and final. Initial is given here 0.250. Yes, very good. Who is this? Siri. Good. Vinaya, good. This is 0. This is 0. Sarayu? Yeah. Final. You need not to type initial. You can simply write I like this. Final. And Shrayu is perfectly correct. All of you are correct. Very good. 0.250. 0.250. What are the major species? Name the major species in the solution. So you're going to focus on the final picture. Check the final picture. So what are the major species in the solution? H plus, NO3 minus. One is missing. One is missing. Water. They all are present in water. It's aqueous. Sorry. Aqueous. What's the pH? Negative log of concentration of H plus. And I think it's the same answer what we were getting earlier because the concentration of the H plus is the same. So it is 0.602. The answer is 0.602. Negative log of this 0.250. So that's how you're going to determine the pH of strong acid. Exactly in the same way, you're going to determine the pH of strong bases also. But there you'll be working with OH minus. Children, anything you're missing, you're learning, okay? You're memorizing things. So keep memorizing them, keep writing, speaking, and whatever punchlines, I'm giving you punchlines for memorizing. Strong acids, 100% dissociated, no rise table, make initial final. Okay, and I told you that equilibrium is dominated by weak components. Who is going to determine the pH of the solution? Whoever is stronger. Whoever is stronger is going to determine the pH of the solution. Now we are going to work on another important concept which we did in unit 4 also. And I think I told you last time also that when we are mixing, yes, Shrihan, actually H plus is the one who is going to determine the pH. H plus, always. Okay, check here. This one, if you carefully observe, you are mixing volumes. 50 ml of HBr is mixed with 150 ml of HI. Who is stronger here? Do we have any weak acid or both of them are strong? What type of acids are there? These. Both of them are strong. Yes, very good. So both of them are going to determine the pH. But we are mixing volumes. And for the pH, we know that we need the concentration of H plus from both of them. I need the concentration of H plus from both of them. Only then I can determine the pH because both of them are strong. But the problem here is we are mixing volume. So when I mix volume, when we mix volume, what happens? Mixing volume. I gave you this line earlier also. Mixing volume will change the concentration, molarity changes. Molarity changes. You need to calculate new molarity. Calculate new molarity. New molarity. Only then you can calculate pH. Because when I'm mixing 50 with 100 or 200, now the total volume changes. Molarity by definition, what is molarity? Molarity by definition is, yes, moles over liter. Can you give me another definition? One more? One more. Millimoles over milliliter. Yes, Shrihan, very good. So you can use any one of them. Like here I'm working with milliliter. I think it's preferable to work with millimoles, right? So rather than converting that into liters, Shrihan will work with millimoles. So calculate new molarity. To know the new molarity, we are going to work out the millimoles over total volume, new volume, total volume in milliliter, the new one. You can say total. I'm asking you to start practicing using this equation because we are going to do plenty of titration questions. Maybe by tomorrow, or not by tomorrow. We'll see how much time we are going to take to reach up to that. Okay, so children, start looking into this concept of millimoles divided by volume in milliliter. Make yourself familiar. Don't worry if your teacher is not using. It doesn't matter. Because every time converting into liters, then multiplying, you're getting a very small number. It's very difficult. So let's work like this. Okay. So what I needed the concentration of H plus. Now I know that HBr is a strong acid. It is 100% dissociated. 100%. So you can make that initial, final. But this time I'm not going to work in molarity because that's changing. Molarity is changing. So don't work in molarity. Make your table in millimoles. Make this table in millimoles. So how many millimoles of HBr? Use this equation. Molarity is equal to, use this equation. From this equation, can I say that millimoles is molarity times volume in milliliter? Can I say that? So I'm going to use this equation, children. So work out the millimoles of HBr. Anyone getting confused here? Because this is, I'm giving you a base for titration questions. I'm converting everything in millimoles because molarities are changing. So I'm not working with molarity. So how many millimoles of HBr? Is it 2.5? 0? Multiply. H plus 0, Br minus 0. Finally, HBr 0. It's a strong acid, 100% dissociated. H plus 2.50 millimoles, Br minus 2.50 millimoles. Is this table clear? So from HBr, millimoles of H plus, which I'm getting from HBr is 2.50. Now I have to make the same table for HI. HI. Complete the equation. Make the equation in millimoles. Who is going to tell me why I'm working with millimoles? Why I'm not working with molarity? You know, earlier I was working with molarity. Now I'm working with millimoles. So what is the reason that I'm working with millimoles? Isabella? Anyone? Sanjana? Saranya, you're not answering anything? Saranya? Vinaya? Why we are working with millimoles? Am I audible, children? Oh, Dhruv, you don't know? What happened? So those who have not understood, please write no, 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 yes, no, no. Please type here. All of you. Saranya, you're not responding. Lasya, I answered, but I asked another question that you're not answering anything for that. You have understood that why I'm working with millimoles. Okay, just write no, yes, no, yes. So why people, why you are not asking questions? You know, we decided to memorize today only. If you're not understanding, then why are you not asking questions? Okay. Are you okay with this that we are mixing volumes? Is this line clear? That in this question I'm mixing volumes. I'm mixing this 50 ml with this 150 ml. Is it okay? Please type here now, yes or no. In the question, we are mixing 50 ml of HBr with 150 ml of the HI. So when you are mixing volume, are you okay? It will change the concentrations because concentration is molarity, which is moles divided by volume in liters. This is volume, right? So do you think this HBr will have the same molarity? No, the molarity will change. Is it okay? Mixing volume will change the concentration, the molarity changes. All of you have understood till here? So when you are mixing two volumes, then molarity changes. And now I cannot say this solution is this much molar. No, it's no longer this much molar. So that is the reason you cannot work with molarity. You have to calculate the new molarity. Calculate new molarity. We have to calculate that. So I'm going to use this equation that molarity is millimoles over volume in milliliter. Because it's easy. You can use moles per liter also. You can, if you want, you can use. But this one is easier. So answer my question. Before you answer, think. So when I'm mixing volume, concentration changes, and I'm asking you to calculate new molarity. And then I started working with millimoles. So is this millimoles of HBr, and here you can see the millimoles here. Volume multiplied by molarity is millimoles, right? Is this millimoles changing when you are adding two solutions or when you are adding water? Is the millimoles changing, children? You are adding HBr in HI. Yes, millimoles are not changing. So that is the reason I'm asking you to work in millimoles because that's going to stay the same. I'm adding this into this. I'm not adding any HBr extra. I'm not saying that, okay, I'm adding more HBr into it. So the millimoles, they will stay the same, right? So work with millimoles. Is it clear that why we are working with millimoles? Who can type now? Why are we working with millimoles in this question? We are not working with molarity, we are working with millimoles. Vinaya, what do you think? Sarayu? Saranya? Very good, Vinaya. But why the molarity changing, Vinaya? In this question, molarity changing. Why? It's still there on the whiteboard. Yes. Okay, children, only Vinaya is typing the answer. Is it clear to all of you? Isabella, is it clear? This concept is clear? Okay, okay, no problem, Lasya. Okay, so Sarayu, is it clear? Fine. So that's the reason we are working with millimos. I discussed these things in Unit 4 also. We did plenty of questions. Calculate the new molarity of the ions, concentration of ions. Very popular question. Okay, so now we have to do the same thing with HI. I'm going to work with millimoles because you are mixing HI with HBr. It's a strong acid, 100% dissociated, 100%, right? Okay, initial, final. Work with millimoles. Who is going to give me the millimoles of HI? Equations are already written. Who is going to give the millimoles of HI? Multiply these two. Practice these equations. Millimoles is equal to, yes, please type the equation here. All of you, please type the equation. Millimoles equals to, we are going to use it a lot in your titration. It should be your now next favorite equation. Millimoles equals to, yes, Vinaya, very good. Molarity times volume in milliliter. Yes. Sarayu, can you type this? Yes, Sanjana. Good. So, Sanjana, how many millimoles are there of HI? Keep practicing, keep memorizing, try to reason out, ask questions here. It's 15? Okay. Don't write mm3. Mm means millimeter. It's a standard unit, right? Yes, millimole. 15. Initially, how much H plus? 0, 0. Finally, how much HI? Final picture, you all know. Yes, H plus 15, I minus 15. How many millimoles of H plus you are getting from HI? 15. What are total millimoles? Total millimoles of H plus is 15 plus 2.50, isn't it? From HBr, from this table, then from this table, you're mixing them. They are in the same container. They are present together. So in total, how many millimoles are present? I cannot use this millimoles to know the pH. I need the molarity now, new molarity. So what's the new molarity? Molarity is millimoles over volume in milliliter, total volume. And the total volume is, yes, V total. After mixing two, what is the V total? Yes, children, V total. Yes, anyone? V total. Total volume of the solution after mixing. Isabella? Yes, 200 ml. 200 ml. Total millimoles 17.50. Total volume 200 ml. That's the molarity. Go for three significant figures. No, two significant figures. This number has two. This also has two. We'll go for two significant figures to get the molarity. 0.088. Get the pH. And we know that pH is negative log of concentration of H plus. And this is the concentration of H plus, 0.88. Oh, 0.088. Yes, you're right, Sanjana. Children, there is a zero here. So it is negative log of 0.088. Get the answer in two significant figures. pH into sig fig. All of you are going to type it. Pick up your calculators, press negative log, plug in the concentration of H plus 0.088. Enter. What's the answer? 1.1 is one significant figure. Shrihan, Vinaya, you're going to count sig fig after decimal. Yes, that's the answer. 1.06. Count after decimal. Shrihan, I explained so many times. Today also I said. In the last class also we did. I've said this many, many times that in the pH, pOH, pKa, pKb, please don't get diverted by family members talking around you and don't get indulged in talking to them in between. You miss the lines then. pH, pOH, pK, pKb. Sig figs counted after decimals. This I explained in the last class also. Sig figs counted after decimal. Can you write down this now, Shirian? Before decimal, whatever number is there, like this 1 is there, it means it is 10 raised to the minus 1. It's an exponential number. So exponentials are never the part of sig fig. So sig figs are counted after decimal. Write down this line, those who have tendency of forgetting it. Write down this line. You can call them as important points to memorize. Keep repeating in your head. So is this question clear? Can I give you one similar question? Would you like to try? One similar question. There is an acid Ha, exactly same question. Strong acid Ha, strong acid Hb. The concentration of strong acid Ha given to is 1.0 10 raised to power minus 2 molar in 100 ml. This is 100 ml. Hb is 1.0 times 10 raised to power minus 1 molar. This is also 100 ml. These two volumes are mixed. V total now is 200 ml. We are mixing them. What's the pH? So I'm not going to solve it. You're going to solve it and give me the pH. So follow the sequence. Get the millimoles of H plus from here. Millimoles of H plus from here. Add them to get total millimoles of H plus, you have the V total divided by V total in ml, get the molarity, take the negative log of molarity. You're calculating the new molarity because you are mixing two volumes. This is the sequence of doing the question. Waiting for the answer. How many millimoles of HA are there? Mhm. Multiply these two. Molarity times volume in milliliter is 1. Yes. How many millimoles of HB are there? Total millimoles, total volume. What's the concentration of H plus? And what's the pH? You're going to use two significant figures in your answer. I have to place decimal here. Now use two significant figures. pH is, okay, 1.26 or 1.25. This last number, 5, 6, is acceptable in AP also. Okay, because there is uncertainty in the measurements. So everybody is giving you 1.26. Is it okay? Now you have understood how to do these type of questions. Okay. Now these questions are very simple. Now this is another type. I'm giving you different types. Like this is just a strong acid, molarity. You are not mixing volume. You can just simply take the concentration of H plus as the concentration of strong acid. So here I can say the concentration of H plus is the concentration of HClO4. It's a strong acid. Same with this. And we are not mixing any volume. So these questions are very, very simple. But over here, we are mixing volume. So I asked you to calculate the millimoles of each acid, millimoles, then total millimoles, then divided by total volume. This is how you were working in this question. See, every question, depending upon what type of information is given, you have to change your method. And then you were calculating the new molarity, and then you were taking the pH of that molarity. Now I'm taking you another type of question. This one. This question is based on dilution law. Dilution means adding water. Over here, if you see, they have given you a concentrated acid, 12 molar. If you calculate the pH of this concentrated acid, it will be minus. Is HCl strong acid? So the concentration of H plus will be same as concentration of HCl because it's 100% dissociated, means 12 molar. What's the pH? Negative log of 12. So I'm sure it is minus 1 point something. Go for two significant figures. Minus 1.08. That's the pH. Now they want to take this solution, they want to add water and make a solution which is 1600 ml. This is the total volume, V total, finally. V total is 1600. So what they have done, they have added water. You are mixing volume. The concentration will change. They want to change the concentration so that pH will be this. From this pH, they want to come on this pH. So you are adding water. Anyone remember dilution law? Dilution law, unit 4. Dilution law, when we add water, moles, millimoles are not changing. So the molarity times volume, which is your moles or millimoles, if you take in milliliter, then it's millimoles of the concentrated solution is equal to molarity times volume of the diluted one when water is added, because you are just adding water, nothing else. So of the diluted one. You remember M1 V1 equals to M2 V2. M1 V1, these are the moles or millimoles before adding water. M2 V2 after adding water. So before adding water, whatever moles are there or millimoles are there, on adding water, the number of moles will remain the same because we are just adding water, nothing else. Please remember this law. This we have done in unit 4. Any one of you could recall it? So please type here dilution law. Dilution law. Type here. All of you please type the dilution law. Shrihan, am I audible, children? Hello? Okay. Yes, dilution law. So Saranya, can you tell me why this M1 V1 equals to M2 V2? Give me the reason why you're using this equation. What is the meaning M1 V1 equals to M2 V2? Dhruv, Shrihan, you are playing with the tools of the Zoom. What is the reason? So please understand the reason. The moles before dilution, before, and the moles after adding water are equal. Yes, yes, Ashita. Ashita is giving me the reason. So she was the one who was listening very carefully. Moles before dilution and moles after dilution. Dilution means adding water. We are just adding water. We are not adding the solute. We are not adding any more quantity. We are just adding water. So the moles are not changing. These are the moles. Moles. Okay. So we are going to use the dilution law here. M1 V1 equals to M2 V2. This is before dilution. You can assume anyone before dilution. You can use any part as before, any part as after. And this one is after. So now let's see what all is given. Is M1 given? Give me the value of M1 before dilution. Yes, 12 molar. Yes. Is V1 given? V1? No, that's not given. See, they didn't mention. They are asking you how would you prepare. So I need to know how much volume of HCl 12 molar should I take. So that is not given. Is V2 given? After dilution, how much volume they are asking? V2. Yeah, that is given. 1600 ml. Is M2 given? The molarity after dilution. And that is also given as pH. It's a strong acid. So the molarity of this acid, when the pH is this, it is 10 raised to power minus pH. It's a strong acid, 100% dissociated. So whatever is the concentration of H plus, that is the concentration of my acid. So 10 raised to power minus 1.50 molar. Can you see? M1 given, M2 given, V2 given. Can I work out V1, children? Yes, plug in here. Yes, Sarayu, you are doing calculations now with me. M1 is 12 molar. V1 is I want to know how much this concentrated acid should I take. M2 is 10 raised to power minus 1.50. You remember this equation? V2 is 1600. Get the V1. And I'm giving you a flask, round bottom flask, which are generally used to make standard solutions. This has only one mark here. This is 1600 ml because final solution is this. So I've taken a round bottom flask of 1600. Now in this 1600 ml, I'm going to make hydrochloric acid of 1.50. How much volume is this, children? You calculate it? Just plug in the value in the calculator as such. Hmm, What is this, Vinaya? 4.22 ml? Okay. Ml, right? Milliliter. Milliliter. Yes. Okay. Now, how to prepare the solution? How would you prepare making of the standard solutions? Write all the steps how to make a standard solution. Unit 4 again. We did how to make a standard solution in unit 4. We did plenty of questions there. Okay, so watch the video. Unit 4 is very, very important, children. If you are missing it, watch it. Most important unit is unit 4, unit 7, unit 8, unit 9, unit 5. Unit 5 is simple and it's very short also and it's very simple. 4 is very important. Unit 2 is very important. Unit 1 is just basics, moles, grams to moles, moles to grams, like this, molarity. Unit 1. It's just basics. Okay. Now I'm teaching you this again. How would you prepare? So I'll take a 1600 ml of the flask and I put water first. I'm going to place water. I'm going to fill it half with the water. This is water, H2O. Now I'm going to take a graduated cylinder because they will ask you to write down all the steps. I'll take a graduated cylinder. Graduated cylinder. In that, I'm going to measure this 4.2 ml of the acid. This is the acid. Let's say this mark is 4.22 ml. Now, you're going to add this acid drop by drop, drop by drop. Acid in water, acid in water. You are not going to do other way around. Means you are not going to take acid first and add water. Because if you do that, then the solution will jump out. it can give you burn injuries because this HCl is very strong. You can see here. If a drop of this HCl, if it comes in touch with the skin, your skin will burn. So the advice is take water first, half of the flask, add this acid drop by drop, and make the volume up to here, here, and then use a dropper for adding extra water with the help of dropper. These are the steps we discussed earlier also. Use a dropper and add drop by drop so that water touches this level, and stop. Your eye should be here. You should be looking at the same level, not from the bottom, not from the top. Don't try to see from the top or from the bottom. This is how we make a standard solution. Very important questions from Unit 3. These are lab-based questions, lab questions. So making of the standard solution is very important. So are we clear about this question? Sarayu. Okay, I'm asking a question what we have done just now. Children, you are not typing yes or no. Dhruv, is it okay? So can you answer my question? Okay, there is a concentrated NaOH solution. I'm going to dilute it. Dilute means I'm going to add water, right? So what should I do? This is the conical flask. The conical flask has a mark at 100 ml. 100 ml. So what should I add first? First, I'm going to add water. Then I'm going to add drop by drop concentrated solution. So write down this line. Concentrated solutions, anything, any base, any acid, anything, any chemical, concentrated concentrated solutions are added drop by drop in water as a precaution. Drop by drop in water. You are not going to add water in like you take concentrated and then try to add water into it, the concentrated solution will jump out. So take concentrated drop by drop, add it in water. Write down this line, children. It's a lab precaution which generally we are doing with acids and bases. Okay, so moving on. Now we are going to calculate the pH of bases, strong bases. Check this. We are calculating pH, so be careful. Now NaOH is a, do you know all your strong bases? Who is going to give me the list of strong bases? I gave you two rules in the last class. First group, hydroxides and calcium 2 plus, strontium 2 plus, and barium 2 plus. Their hydroxides are strong bases. Rest all are. Sarayu, you are there? You're understanding everything, Sarayu? So answer this question. Sanjana, ready? Asya, Sanjana. I'm Generally not calling the name of the students who are very regular in answering. Okay, so those who feel that I'm not calling the name, just appreciate yourself. It means you are answering. Okay, NaOH, is it a strong base, weak base? Identify. Strong, weak. Saranya, it's a strong base. Yes. So if it is a strong base, it's 100, whatever you know about strong, is 100% dissociated. No rise table. No rise table. So what are you going to do? You're going to make initial, final. Are you mixing any two volumes here in this question? Are you mixing two volumes? So don't worry, molarity is not changing. You can work with molarity, right? So let's work with molarity in the initial, final. Initial, final. Complete the equation. Who is going to complete the equation? Show me the products. Show me the products. Mhm. NaOH going to split apart 100%. Yes, very good. Na plus aqueous and OH minus aqueous. Perfect answer. Okay. Initially, now complete this initial and final. Initial is, this is 0.10. Na plus is 0. OH minus is 0. Final 0. 0.10. 0.10. So what do you have? Concentration of OH minus, which is 0.10 molar. What can you calculate? pOH? What are they asking? pH. Get the answer, please. They are not asking pOH, they're asking pH. So first calculate the pOH and then convert that into pH. Okay, very good, Siri. That's the right answer. pH is 13 because pOH is 1. See, it is 10 raised to power minus 1. Yes, Sanjana, good. Is this clear? I'm leaving this question. I'll do it in the last because this question is going to trouble you, but it's not a big trouble. You remember I gave you one line, whoever is stronger will control the pH. So we'll see how to do B later on. Let's do C first. So C is also NaOH. So I think the same table, same question. So can you complete the table? Can you calculate the OH minus and the pOH and the pH? Complete the table, children. And get the pOH and the pH. You'll get a negative pOH this time. pOH is negative. Negative 0.3010 is highly concentrated, more than 1 molar. So negative pOH. And pH will be more than 14, right? So it is 14.3010. So the range of pH is 0 to 14. You remember we did the scale 0 to 14? It's not negative, Sanjana. It should be positive, right? Good. The range is 0 to 14. If you go above 14, then it means you are dealing with very strong base. You cannot touch it. It can burn your skin. If you go in the negative pH, negative pH, negative pH means very strong fuming acids. They can cause very serious burn injuries. Okay, fuming acids below 0. 0 means 1 molar. That's also strong. It's also not very diluted. It's still strong, but below zero, they are really fuming acids. We call them as fuming acid. When you open the cap of that bottle of the concentrated acids like 12 molar, 16 molar, you can see fumes coming out. Even if you inhale those fumes, it can harm you. I've seen myself, I was using them. So when we open the cap, our professor used to tell us, okay, stay away from the bottle, open it slowly, and point it in the other direction when you're opening it. They are so concentrated. So we are clear about question C part. Now we are on the B part. Let's do the B part. B part is very different. So please pay attention, those who are not listening. I will ask questions. Okay. Initial final is a strong base. 1.0 times 10 raised to power minus 10 molar. Na plus 0, OH minus 0 initially. That we know how to do it. And what's the pOH? Can you get the pOH, children? Concentration of OH minus is 1.0 times 10 raised to power minus 10. What's the pOH? What's the pH? Oh, Dhruv 4. Dhruv, your answers are coming very less today. I want all your attention here. Okay, but pH 4 is an acid or base? But I have given you NaOH. How come the pH is less than 7? pH cannot be less than 7. So it's wrong. It's wrong. Why it is wrong? Then what should be the answer and how can I calculate the answer? Right now is indicating me that NaOH is an acid, which is not correct. It's a base. 100% is a base. 100% pH is more than 7, not less than 7, sorry, more than 7. pH should be more than 7. It's a base. It should be, it must be. Okay, so how to calculate that? Now you focus on water because everything you're doing in water. Whoever stronger will control the pH. So what's the concentration of OH minus from water? From water, pure water. Remember the concentration of OH minus from pure water? Isn't it? Now, can you see that this is more? This is more than this. So how can you ignore it? You cannot ignore it. So what's the total concentration of OH minus now? Is 1.0 times 10 raised to the power minus 7 plus 1.0 times 10 raised to the power minus 10. If you work out this in your answer, in your calculator, it will be 1.001 times 10 raised to the power minus 7. It will be, can you work out the pOH now? pOH. It will be slightly, pOH will be slightly less than 7. It is 6 point. So let's not do approximation because if we do approximation, then it will become 7. This is the pOH. Now get the pH. And you can see the pH is 7.003. Isn't it more than 7? It is more than 7, right? So if in the exam they have given you a strong base with very low concentration, then add the concentration of OH minus or H plus from water and then calculate the pH. But still is basic. Earlier it was 4 pH. 4 is acidic. That was totally wrong, right? Now this is acceptable. It's nearly 7. So this pH is controlled by water. pH is very close to pure water, isn't it? So whoever is stronger will control the pH. We are understanding this? Whoever is stronger will control the pH. Okay, I'm going to clear it. I'm going to give you one question and all of you are going to answer it. Those who have not understood, they can ask questions. So I'll call the names. 1.0 times 10 raised to power minus 11 molar hydrochloric acid. Get the pH. It's a very strong acid. It's 100% dissociated. You can hear me, children? Yeah. It's 100% dissociated. So the concentration of H plus is the same. Compare it with water. So don't calculate like this. If you calculate like this, pH is 11. pH 11 means base, strong base, in fact. But HCl is not a base, so this is wrong answer. So don't give me this answer. So yes, start doing it and put the pH here in the chat. pH of 10 raised to power minus 11 molar HCl. Isabella, you're doing it. Sanjana, Sarayu, Shrihan, Siri, Vinaya. Please do it. You know what to do? Now, water is the stronger. Water is the one who is going to control the pH. Get the H plus ions from water. So how many H plus ions you will get from water? How many H plus ions? You know, pure water. Yes, Vinaya, very good. This is from pure water. And how many H plus ions you are getting from your hydrochloric acid? So definitely you can see that water is the one who is going to control the pH. pH will be slightly lesser than 7. You add them, you will get 1.0001 times, you'll get this. Get the pH. I gave you this equation also, 7 minus log. When you take the negative log of this, minus 7 will become 7. And this will become minus log 1.001. You can see that 7 minus means slightly lesser than 7. What is this, Vinaya? 0.155? Yes, 6.99. Only Vinaya is working with me. Dhruv, are you working? Dhruv, Shrihan, Isabella? Yes, Lasya, good. All of you are getting this answer? Srayu, your answer? So, is this solution acidic? Yes, it is acidic. It's not basic. The pH is not 11. pH is less than 7. So, this question is also important. This question I have seen in multiple choice questions. So, if you have a very dilute acid who is giving you H plus ions concentration lesser than that of water, then just take water as the major controller of the pH, and pH of water is 7. If it is acid, pH will be slightly lesser than 7. Like there is a question on my website also that there is 1.0 times 10 raised to power minus 9 molar HNO3. And they said, okay, pH of this pH options. One option, pH is 9. Second option, pH is 7. Third option, pH is 5. Fourth option, pH is 6.99. So according to you, which answer is correct? It's HNO3. It's an acid. So what answer is correct? Without calculation, you can do it. There's no need of calculation. So is this pH 9? Is it correct? No. Is it correct? Is it neutral? Neutral like water? No. It's not neutral, right? It's not pure water. Is pH 5? No, you cannot say that, right? The answer, it is closer to 7. Remember this line, it is closer to 7. If it is acid, slightly lesser. If it is base, slightly more. So you can answer this question without calculation. So we are good with the calculation of pH of strong acids and strong bases. Okay, now I'm going to, okay, one more question before we move on. Okay, this question. We'll do only one of them. Only this one. Can you write down the dissociation of this base? You already know it's a strong base. Sarayu, you know that? You know, barium, strontium, calcium, they make strong bases. So strong means 100%, no rise table. I'm going to make only initial and final. After dissociation, yes, who is going to complete it? Complete this. Mhm. Yes. It's 2OH minus, Vinaya and Siri. If you do this error, you won't be able to get the answer. Okay. What is the initial concentration of barium hydroxide? 0.015. Initially, how much barium? Finally, how much barium hydroxide? How much barium 2 plus? How much OH minus? OH minus now. How much OH minus? Last year, it is OH minus. Are you taking care of this too? You have to take care of this too. One barium hydroxide will give you 2 OH minus. So it is 0.030. Yes, Ashita. Yes, good. Should be multiplied by 2. So what's the concentration of OH minus? What's the pOH? So this question can be there in the exam. It's so simple. But if you do error here, you won't be able to get the answer. pOH and then pH. pOH you will get less than 7. pH you will get more than 7. It's a basic solution. Children, you have understood this? Okay. So now I'm going to discuss few questions without doing them. Can you look at this question? We are not doing, okay? We have made so many initial, final. We know it's a strong base. This is a strong base. Can you tell me what's the concentration of OH minus I will get here? You can make that table, initial, final, and then finally see what's the concentration of OH minus. Yes, this is the initial concentration. Isabella, what's the concentration of OH minus finally? Yeah, that's right. Double of this. Yes, yes. It's double of this. Sarayu, your answers are not here. You are there in the class? Okay. I hope you're understanding. So, what's the pOH? Yes, Saranya, good. And what's the pH? So, are you clear? Like, without even making that initial final table, you can see that this is 2. So, whatever concentration is there, it will be OH minus will be double of that because it's 2. Okay. One more question. What are the major species in the solution? Major species in the solution. Mhm. It's a strong base. So, what will be the major species in the solution finally? Yes, very good. Calcium 2 plus, OH minus. Now, I'm just asking species, so you can avoid saying 2, right? I'm not writing equation, I'm not asking equation. So, calcium 2 plus, OH minus, what else? Water. These three will be major. Out of calcium 2 plus and OH minus, whose concentration will be more? Which one will have more concentration? Calcium 2 plus or OH minus? Of course, water, yes. Water, just leave that out of these two. Concentration is water. We don't talk about the concentration of water because it's the solvent, right? What about the concentration? Which one is going to have higher concentration? Calcium 2 plus or OH minus? Who will have higher concentration? Mhm. Yes, the concentration of OH minus will be double of this calcium 2 plus. Double. It's like this. This is how they are related. If this is X, then OH minus will be 2X. Double. Okay, now we are going to discuss the next question. KOH, strong base, weak base. KOH. Is it strong or weak? KOH is a strong base or weak base? Answer it. Yeah, why you're taking so much time? First group K is in the first group. You have your periodic table next to you. So check, potassium is in the first group. So it's a strong base. How to do this question? Just give me the planning. They have given me grams of KOH. What should I do? I want to calculate OH minus, pOH and pH. What should I do? From grams of KOH, I can calculate moles of KOH. From moles of KOH, I can calculate molarity of KOH. Molarity. From molarity of KOH, I can calculate molarity of OH minus. From this molarity of OH minus, I can calculate pOH. From pOH, I can calculate pH. Any doubt in this? So whatever is the molarity of KOH, same will be the molarity of OH minus, because in one KOH you have this, the ratio is 1:1. 1 K, 1 OH. Are you clear about this sequence of doing this question? Okay, ready for next? C part. Give me the sequence of doing this question, the way I gave. I should start with grams of NaOH, the one which is given to me. Where should I go from here? Please type here, where should I go? From grams to moles of NaOH. Yes, moles of NaOH. From moles of NaOH, where should I go? To molarity of NaOH. Yes, only Vinaya. You know, children, she's the new student. What about rest of you? You're not answering? Okay, who is going to tell me how to calculate the molarity from moles? I calculated the moles, I know how to do that. From moles, how to get the molarity? How to get the molarity from moles? Yes, the volume is given here, see, per liter. Okay, from molarity of NaOH, I can get the molarity of OH minus. And from molarity of OH minus, you can get pOH. From pOH, you can get pH. So this question can be there in the exam. Is it okay? Okay, Lasya, very good. So that's the story about your strong acids and strong bases. Now we are going to work with weak acids and weak bases. Weak acids and weak bases, they set up an equilibrium. There is an equilibrium. They are not 100% dissociated. They are not fully dissociated. So whenever you see a weak acid or weak base, so remember, not fully dissociated. Their Ka or Kb values will be less than 1, less than 1. They are always governed by the equilibriums. Means we cannot say that, okay, only products are there, reactant is 0. The way we were making initial final earlier. Now there is no initial final because there is an equilibrium. We have to work with Rice table. So please write down these lines. You know everything. You know the meaning of weak acids and bases, not fully dissociated. They have Ka, Kb values less than 1. They are going to set up an equilibrium in water. So you have to make a Rice table. And from the Rice table, you will take out the concentration of H plus. And from the concentration of H plus, you will work out the pH. That's how you're going to do these questions. So these questions are simple, very, very simple. So we'll try to finish today only how to calculate pH of weak acids and weak bases. Ready? Okay. Before we do this question, can you look at the Ka values? Are they visible to you? Ka values. I want you to focus on the Ka values. I'll ask some questions from here. You can see the Ka values now. Okay. All the eyes on the Ka values and answer my questions. These Ka values, are they greater than 1 or less than 1? The Ka values are greater than 1 or less than 1? All of them. What does it mean? These acids are strong or weak? Sarayu, you didn't answer this question. Sarayu, Dhruv, Shrihan, where are you? Answer these questions. Ka values are less than 1. What does it mean? Less than 1. What does it mean? What is the meaning? Meaning is they all are weak acids. Yes, they are not fully dissociated. They are weak acids. So whenever there is a Ka value less than 1, you can classify your acid as weak acid. Very important, very simple thing. But generally we have tendency of forgetting about it. Okay, I'm highlighting two acids here. One is this, other one is this. This one. Their formulas are given. Which one is stronger acid? Which one is stronger acid? You can see the Ka values, compare the Ka values, and then you can answer. Of course, both of them are weak, but which one is more stronger or more weaker? So which one is more stronger out of these two? Yes, Saranya, very good. Yes, HSO4 minus is going to be stronger. Can you give me the conjugate base of this HSO4 minus? The conjugate base of HSO4 minus. Mhm. Conjugate base. You know, acid, they can get converted into conjugate base, remove H plus, H with plus. You are removing H with plus. So HSO4 minus already has one minus. So its conjugate base is SO4. So Saranya, you didn't place any chance. Is it going to be neutral or it will be more negative because you are removing H plus. You are removing H plus. So it is 2 minus, yes. Can you give me the conjugate base of this one? And remember, this hydrogen is acidic, the one on the oxygen. So the hydrogen on the oxygen is acidic. Can you make the conjugate? So don't remove hydrogen from the carbon, remove from oxygen. So what's the conjugate? Mhm. Remove H plus means hydrogen with a plus charge. Remove from here. Remove this hydrogen with a plus charge. So what is left? O C6 H5 minus. This one? Minus, yeah, okay. Fine, no problem. So your which one is a stronger conjugate base? So now you have seen two bases here. One is sulfate, Other one is this phenoxide. We call it as phenoxide. Don't worry about the name. So which one is stronger? Which one is stronger conjugate base? You already know weak acids, they give you stronger conjugate bases. Weak acid will give you strong conjugate base. Strong acid will give you weak conjugate base. Now you already identified HSO4 minus stronger than this phenol, right? Stronger than phenol. So who is going to give you stronger conjugate base? Which conjugate base is stronger? Of the weak, this one. That is C6H5O minus. We can write like this, or it's okay, whatever way you have written. You've understood this? So you can compare the Ka values. You can decide their strength from the Ka values. And from the strength of the acids, we can compare the strength of the conjugate bases. Can you calculate the Kb value for this conjugate base, sulfate minus, for this one? SO4 2 minus. Can we calculate Kb value, children? Mhm. You know the equation? Ka times Ka times Kb is Kw. You know it? So Kb will be Kw, which is 1.0 times 10 raised to minus 14 divided by Ka, which is 1.2 times 10 raised to power minus 2 for this sulfate. For this phenoxide, C6H5O minus, Kb value will be 1.0 times 10 raised to minus 14 over 1.0 times 10 raised to minus 10. Now you can compare their Kbs. You can see this Kb is quite big. This is just 10 raised to minus 4. And this Kb is near approximately minus 12 or maybe 11. See the values? So which conjugate is stronger? This one. This is stronger. Which acid was stronger? This one. This acid was stronger. This one. But the conjugate base of the weak acid is going to be stronger. So mathematically also you can try to understand the concept. So are we okay with the meaning of the table, comparison of Ka, Kb values? So all these are multiple choice questions in the examination. Now we are starting with how to calculate the pH. Very simple concept, children. I know you are tired, but we'll try to finish this, and after that I'll end the class. Okay. So when these type of questions will be there, last year review classes will start once we are done with everything. We are still left with major part. I need to take some extra classes, children. If you don't want to extend this class for 30 minutes, then you have to give me option for some extra class. And extra classes I can take only on Saturday, Sunday mornings. Who all are willing to give extra classes on Saturday, Sunday mornings? Then I can finish the everything before 20th March because uh, I'm planning to start your review classes by 22nd. You know that you need review classes very strongly. I want to give you intense review classes. Saturday, Sunday. Saturday, Sunday. Okay, time. Time will be, I tell you time. 10, not 10. Okay. This is time change this week, right? So right now, whatever time is there, 10 a.m. EST and 7 a.m. PST. CST will be 9 a.m. 9 a.m. CST. I cannot go beyond that because it will be late night for me. This is the correct timings. This I cannot go beyond that. Before that, PST children they start saying that we cannot get up so early in the morning. So that's the reason this is the only option. There is no other option. And Isabella, no. In Indian Standard Time, it will be 8:30. 8:30 p.m. for the children who are in India. IST. 8:30 is okay, Isabella? Yeah, but Ashita, if you can manage, because I took these classes for one more group, group two, and I did the same thing with group one, and group one is already over. They were over in the month of December. So complete December, they were taking these classes, Saturday, Sunday, extra. Other than 2 classes per week, they were taking these extra classes. And group two is going to be over this week. They are done. Their review will be starting from 11th March. So only your group is because you started late. All of you started quite late. So if you can give me this option, then I will finish everything. So those who have some problem, then they can watch the recordings. Will that be okay? Yeah, Shirian, you can manage with the recordings. I'm not going to go for very for throughout the month. No, maybe 2 weeks, 3 weeks, maybe just 10 hours. Because every Saturday, Sunday, if I take the classes in the mornings also, then I think within 2 weeks, only 2 weeks, 2 Saturdays, 2 Sundays is more than enough. No, we are going to have for 2 days. Then I can drop this 30-minute class because 30 minute is not helping us much. So children, you're understanding the requirement here?